All right. They'll say, what can we do if we cannot demonstrate all three requirements to definitively establish contributory cause? Which is that we could be due to the fact it may be unethical to perform an RCT. So in such cases, we have to examine the supportive or ancillary criteria, which are the strength of the relationship, dose-response relationship, consistency of the relationship, and biological plausibility. And this is very common in the public health field to make scientific judgments. There's a large variety of criteria that we can debate, but these four are commonly used with little controversy. So these criteria are widely accepted with minimal debate, and we'll explore each of them on the next slide. All right, so now starting off with our list, we have the strength of relationship. This criterion examines how closely the risk factors is associated with the disease. We want to compare the probability of developing lung cancer in smokers versus non-smokers. To measure this, we calculate the relative risk, which is the probability of developing the disease if the risk factor is present. Say with lung cancer for smokers is divided by the probability of lung cancer for non-smokers, for example. Then next, our dose-response relationship. So in addition to the strength of the relationship, we ask whether increasing quantities of the risk factor are associated with greater likelihood of developing the disease. So say smoking 1 pack versus 2 packs of cigarettes. Does that increase the risk of lung cancer? Then we have consistency, which examines whether studies conducted in different geographical areas and among various populations yield similar results. So for example, numerous studies across different countries, races, and socioeconomic groups have consistently shown a strong individual association between smoking and lung cancer. Then we have the biological plausibility, which here assesses whether we can explain the occurrence of the disease through known biological mechanisms. For lung cancer, we know that the added chemicals in cigarettes that are potentially toxic and can reach the lungs, where they can cause cancer. In short, all of these criteria support the argument that smoking is a contributory cause of lung cancer. All right, so what I have here is a little table that summarizes the process of evidence-based public health in establishing a cause and effect relationship. For our first step, we start with group associations, which help generate hypotheses about a potential link between smoking and lung cancer. These associations are initially observed in populations and suggest further investigation. For our next step, we move on to the definitive requirements to establish contributory cause, which I discussed earlier. These include proving that smoking is associated with lung cancer at the individual level, precedes the disease, and can alter the disease outcome, as I mentioned previously. Then step 3 is using the supportive criteria to make our scientific judgment. This involves looking at the strength of the relationship, dose-response relationship, consistency across studies, and biological plausibility. In short, this process helps strengthen the argument cigarette smoking is a contributory cause of lung cancer and not just an association or coincidence. All right, so we're talking about contributory cause. So what does this imply? Well, it's important to understand that what a contributory cause actually implies, which is that existence of said cause implies the cause increases the chance that the effect will develop. In short, this increasing the chance does not guarantee the effect. So an example is back to the smoking/lung cancer. Some individuals who don't smoke still get lung cancer, so it's not a necessary cause, implying that there are other contributory causes. And for some of those that do smoke, they don't develop lung cancer. So here the cigarettes aren't a sufficient cause of the lung cancer. So that means there must be factors that protect against it. So for every good researcher, they're always thinking of their next 3 projects based on whether their hypotheses was proven true or not. They're also always thinking beyond their current findings. They ask what other factors could be involved. The goal is not just to prove or disprove the hypothesis, but to continuously refine and expand our understanding. Like a scientist who challenges established theories, the researcher is constantly exploring new avenues and reconsidering their conclusions. Now note this is important because our minds often jump to conclusions about cause and effect relationships. So you all see this in the modern day too, in everyday language. Think of newspapers and news outlets. They frequently draw conclusions based on less rigorous examination, and they use terms like due to or blamed on without solid evidence. So that is something you have to be careful of. All right, so now here we'll be going over our recommendations. In short, what works to reduce the health impact. So all these suggestions and recommendations are based on incorporating sound evidence. In order to make these recommendations, we must consider two key factors, the quality of the research and the magnitude of the impact, which not only takes into account the efficacy or benefits, but also the harms or safety. The quality of the research is scored based on the type of investigation and how well it was conducted, as well as its relevance whether it measured clinically important outcomes. For example, well-conducted randomized control trials are considered the highest quality evidence. The magnitude of the impact refers to the net benefits, meaning the benefits minus any potential harms. When assessing this, we not only look to the efficacy or benefits of an intervention, but also its harms or safety. It's about weighing both sides to determine if the benefits outweigh the risks. So in short, evidence-based recommendations are guided by two main criteria, the quality of the evidence and the magnitude of the impact. Each of these criteria gets scored to help guide our final recommendations. All right, so now to make our evidence-based recommendations, we must combine the scores for the quality of the evidence and the magnitude of impact. First, the quality of the evidence is scored based on the type of research and how well it was conducted. RCTs are the gold standard, but cohort studies and case control studies still provide valuable information. Note expert opinion ranks the lowest on the evidence hierarchy, but can still be useful for filling in gaps when there is limited data. For magnitude of impact, we categorize the level of impact the intervention has as substantial, moderate, small, or 0/negative. A substantial impact means intervention may work exceptionally well for a small group or could have a modest benefit for individuals but can be applied at a much larger scale. By combining both the quality of evidence and the magnitude of impact, we can classify the strength of recommendations graded as A, B, C, D, or an I. All right, and the classification system shown here for recommendation is as follows. If it has grade A, it means this is a must. It means a strong recommendation in favor of the intervention, and it should be generally used in practice. Grade B is a should, meaning the intervention should be used unless there are specific reasons not to. Grade C is a may use. This indicates that the decision should be based on individual judgment, considering the specifics of the situation, so it's more flexible. And then a grade D means don't use. So this is a strong recommendation against using the intervention. Maybe this treatment has the same benefits as another, but this one specifically has more side effects. The next grade we have is an I, which is insufficient, or in short, you don't know. This means that the evidence is inadequate to make a definitive recommendation for or against the intervention. So a couple examples of an A or B grade could be federal, state, and local taxation increases, and then say a clean indoor air legislation, meaning no smoking. Now examples say of grade D, say using a chest x-ray for early detection. They may detect cancer at a slightly earlier stage, but not early enough to change the course of the disease. So CT scans are the preferred method to, say, finding small lung cancer, for example.